In this video, I'm going to show you how to use Gauss-Jordan Elimination with this interactive applet. Here's the URL for it. Here's our system of linear equations. We're just doing two variables here. And how it works is you need to put in the coefficients of the variables and then the constant at the equal sign separated by commas on each row. So 12, 3, 8 separated by commas, 6, 1/2, and 22. Click use this matrix and it creates the matrix. Now we are trying to get to this, a 1, 0, a number, a 0, 1, and a number. And then that's going to be the solution, because this area here is the x variables, right? That's what these were, the 12x and the 6x, and these are the y's. And these are the y's here. So 3y, 1/2 y. So when you rewrite this, it becomes 1x, and then it becomes equals this number. And over here, it becomes 0x, 1y equals this number. And that's how the solution is created, because there's a 0y here, and that means 0, right? So we don't need it. So that's why if you get the 1 here, that's the coefficient for x in this column, and 1 coefficient for y. So let's do it. I'm going to walk this problem all the way through, and then I'll walk a more difficult one. So the goal is to get a 1 first someplace. So I'm going to multiply by 2 across here to give me a 1. So that would be row 2, multiply row 2 by 2. I do that, creates a 1. Once I get a 1, I switch to making zeros above and below it. So now I need to make a 0 up here on the 3. In order to do that, I need to multiply row 2 by -3 and add up. That will get 0 in that spot. Row replacement. Add -3 times row 2 and then add it up to row 1. And that's row replacement. Created a 0. Now I've got a 0 and a 1. So I need to make a 1 here. The only way to make a 1 here is by division or by multiplication. And here I multiply by 1/24, -1/24. So multiply row 1 by -1 divided by 24. If I do that, I'll get a 1 here. I need that 1 so I can make a 0 below it. So I do the multiply. Right? 1, 1, 0. Now I need this to be 0. In order for this to be 0, I need to multiply the top, this 1, by -12 and add down. So I write that, -12 times row 1, add to row 2. -12 times row 1, add to row 2. And there we have it. The matrix is reduced in row echelon form. X, this is the X column, X is 31/6, and Y is this column, and it has 1Y, because this would be 0x, 1y, so Y equals -18. Those two lines right here cross at the point 31/6, -18. And if we graph them in Desmos, there's both lines, and there's the crossing point right there, 31/6, -18. So this one might be easier to find by graphing, right? And just have a graphing software do it. But what we're doing with this is the baby steps, so we understand from one matrix to the next how this process goes, so that we get these diagonal ones and get it into reduced row echelon form. Now let's do a harder one. Let's look at this, 3 variables in 3 equations. So we put all 3 coefficients, 1, 1, 1, 3, return. 2, 3, 7, 0. 1, 3, negative 2, 17. And create that matrix. The last column are the answers, and then we have x's, y's, and z's. It's the same problem. We need to get diagonal ones. So an x, a y, and a z. I already have a 1 there. That's perfect. So let's create 0 below it. So I'm going to do 2 steps. What we're going to do is multiply this one by negative 2 and add down. Then when that's done, multiply by negative 1 and add down. Because once you have a 1, you create zeros above and below it. There's nothing above it, but let's go below and do it. I'm choosing this one instead of this one. You could choose either. I'm just choosing this one because it's the top left, and that would be my x. All right? So I multiply by negative 2 times row 2, or times row 1, excuse me, and add to row 2. Negative 2 times this and add down. Row replacement. Got a 0. That says negative 2 times row 1, then add it to row 2 and replace row 2. So every value got multiplied by negative 2, and then we added down. Okay. Let's go ahead and take this negative 1 times row 1 and add down to row 3. So do it again. Negative 1 times row 1, but this time add it to row 3. And the reason why I'm doing that is this one will cancel out this one and make 0 there. So I do a row replacement. 1, 0, 0. Now I'm going to this spot because I want diagonal ones. I want that one there. And I want a 0 here. See, now I'm able to multiply by negative 1 here and add up, and it won't change that 1. So negative 1 times row 2, add up to row 1, makes above this one a 0. Negative 1 times row 2, add up to row 1. Row replacement, 0 above that one. Now 0 below it. Multiply by negative 2, add down. Multiply negative 2 times row 2, but then add it down to row 3. I'm making zeros above and below this 1 in the middle now. Okay. Now I need this to be a 1. The only way you can create a 1, if it's not there, is by multiplication. You get zeros by multiply add, but the only way you get 1s are by just multiplying straight through. So in this case, we have to multiply row 3 by a negative 1/13. I have to multiply by a fraction, because that's, like division, right? Divide by negative 13 to make a 1, but really multiply by negative 1/13. So the only way we make 1s are by multiplication. The way we make zeros are by multiply and add. All right, look at this. This is the x, the y, the z. The z is negative 2. We've solved part of it. Now we have to solve the rest. This has to be a 0 and a 0, and we'll be done. So multiply row 3 by negative 5 and add up. Multiply row 3 by negative 5 and add it to row 2. Multiply row 3 by positive 4 and add it to row 1. And there we go. The reduced row echelon form. X is 1, Y is 4, Z is negative 2. And those are the solutions to all 3 of these equations. That's where each of these lines in three dimensions cross. So if we check one, let's check the easy one. 1 plus 4 is 5, minus 2 is 3. And if you put the rest in there, they'll all be true statements, because that is the solution. So that's how you complete the Gauss-Jordan elimination procedure using matrices and getting the answer into row echelon form.